Thank you, and good morning. My name is Luca Ottaviano, and I'm a technical lead at Develer. A few words about me. I've been using Qt for a few years now. I have experience with Qt widgets and Qt Quick, both on desktop and embedded platforms. I've completed more than 10 projects, and yeah, I'm a trainer as well on C++ and the Qt stack at Develer. Okay, now, you may be wondering if the 5 steps that I mentioned in the session title are a marketing move. Yeah, of course they are a marketing move, and it worked. But yeah, don't worry, it's not all marketing material. And let's get the 5 steps right away. So if you want to remote your UI to a browser, you need to do first, you use Qt remote object on the host process to share the needed objects. Then you use Qt remote object on the client process to receive the updates from the host process. The important part is that the rest of the code is left untouched, okay? Then you launch the host process on the local screen. You launch the client process with a suitable command line arguments. Then you connect with the browser to your client application, and that's it, okay? And you can enjoy your application on 2 screens, the local screen and the browser. Thank you. Do you have any question? No, not really. OK, is it really that simple? Some question may pop in your mind now. What about non-Qt Quick UIs? What are Qt remote objects in the first place? How much code do I need to write to support them? What about the security? How many users can interact with such a setup? And finally, which browsers are supported? I'm going to try and answer all of these questions during this session. So the agenda is I will state the problem and the use cases. We will see what are the remoting options for Qt UIs. We'll give you an overview on what I mean by multi-user support, and then some final words and conclusions. So I've started with this problem. I want to interact with the Qt UI from remote without rewriting significant parts of my application. So, for example, rewriting my application, my existing application for the web. So let's say a backend, some JavaScript on the browser is a no-go, because in terms of knowledge, in terms of budget, whatever. A use case may be a headless device. So I have a device without a local screen. Another use case may be remote maintenance of an appliance with a local UI. And the third, for example, may be remote training of personnel. The important part is that I want to target the browser, because the browser is, as of today, is a no configuration option that is always available everywhere. If you have a laptop, you have a browser. You have a phone, you have a browser. You have a tablet, you have a browser, OK? So let's start by reviewing the remoting options that you have with Qt, as with any Qt application. And these options are embedded in the framework. So you can have VNC, WebGL platform plugin, and then Qt for WebAssembly. Let's start with VNC. It's really easy. you just start your program with a command line option, platform VNC. Then you can connect the platform plugins. The platform plugin opens a port, a VNC port for you, and then you can connect with the VNC program, and that's it. So the pros of this solution is that it works with any Qt UI, and it requires no extra coding effort on your side. Okay? You just change the command line platform. The cons of this solution is that it requires additional software on the user machine, so which is the VNC program, the VNC client. It has rather high bandwidth requirements, both in terms of latency and bandwidth itself, because the screen, it has to send screen updates every frame. And it can support only one user at a time. The second option is the WebGL platform plugin, also known as WebGL streaming. With this solution, you start your application with the command line switch platform WebGL. You can then connect with the browser to the port that you specified there. And again, that's it. OK, this is a very complex diagram of what's happening in the background. When you launch your application, so your application is here, for example, an embedded device. And here, there's the client. There's your client. What happens when you launch your application with the platform WebGL is that your application is not started right away. Instead, a web server is launched. Okay? Then, when the client connects, the web server will serve a web page to the client. That web page is fixed for now. It's in the platform plugin. And basically, it has just a canvas and some JavaScript to interpret user inputs. So your application will send OpenGL commands to the browser, which will render them through WebGL on the client. And what about the user input? The input is sent back through a WebSocket to your application. Your application interprets it, and then instead of drawing on the local screen, it just sends the commands to the browser. Okay? This is the whole story, but if you are developing your application, you just need to care that you just want to know that, yeah, you just start the application with platform WebGL, and then when the browser connects, it does stuff, and it renders. OK. The pros of this solution is that it enables remoting, again, with no effort. And it works even without an onboard GPU, because it just sends commands down a socket. The cons is that it doesn't work with raster surfaces, which means Qt widgets. So if you have a Qt widgets application, you cannot use this solution. The performance is highly dependent on network latency only. The bandwidth is not so much after the first connection. So whenever you connect, the browser will download textures and all the assets it needs, and then it only needs updates. So the network latency is it is sensitive to network latency, but it doesn't require much bandwidth after the first connection. It can only support one user at a time. And finally, not all browsers perform well. in my experience, desktop browsers tend to perform very well, while mobile browsers are still not well supported. It may be something that will be fixed in future version. I don't know enough of the web platform to do that evaluation right now. Okay, the third option is Qt for WebAssembly. What is WebAssembly? It is a bytecode format specification that enables JavaScript engines in browser to execute code at nearly native speed. This is a definition taken mostly literally from Wikipedia. When it says nearly native speed, it's nearly native. It's something like it is in the range 50 from 70% of native code, so it performs really well. Notice that WebAssembly is not a replacement for JavaScript, but it's a companion to it. Rendering is still done with HTML elements, Canvas or whatever, and for example, user input is still done with regular JavaScript. The hot point is that C++ applications can be compiled to WebAssembly. You can use a special compiler to compile your C++ code. Instead of assembly for your target platform, you compile it for another platform, which is WebAssembly. And so you have, you have a different compiler for that. Qt for WebAssembly will be in technology preview in Qt 5.13. The pros of this solution is that it runs on any browser and runs well, and it is natively multi-user. So yes, it's just a regular web page that is served by a server, so it's natively multi-user. The cons are that the application is sandboxed, so it can only issue HTTP requests or WebSockets. So for example, if you have your application that is ready, it cannot work with Qt for WebAssembly if it uses, for example, Q processes. Yeah, there are no Q processes on the web platform. Q threads, yeah, I don't know if it's still mapped with web workers. So this solution requires significant rewrite of your application. As I said, it needs a special compiler, and so in the end, it's not yet ready for prime time. Okay, let's talk now about multi-user support. As you may know, Qt applications are designed for a single user in mind. So each Qt process has a global state in memory, and if we want to support more than one user at the time, we need to find a way to share this state in memory between processes. Okay? And how do we do that? How can we let two processes communicate together? Well, it's a well-understood pattern in computer science, which is called inter-process communication, or IPC for short. IPC lets you share data between processes. And yeah, funny, right? And it's you have to see that as divided in two parts. The one is the communication protocol that you're using to communicate stuff, and then a serialization specification, which tells you how the data is encoded on the channel. So let's review communication protocols. There are many options available. For example, on localhost, you can have named pipes. You can have dbus, or shared memory, for example, and much more. And if you are remote, you can use, for example, 0MQ, HTTP. You name one, it's that. As for the serialization specification, we have even more options. We have JSON, we have protobuf, flat buffers, CBOR, and probably many, many more. Okay. How does it fit together? Well, Qt Remote Objects is a complete solution to synchronize Qt objects between processes. It works out of the box for Q objects and Q abstract item models. So if you have a Q object or a Q abstract item model, you just use it. You just tell it the framework that you want to share that, and it will figure out itself how the object is composed using Q object introspection. There are three key concepts in Qt Remote Objects. The first one is source. A source is an object that lives in a specific process and is the source of truth. So it's the actual object that you want to share. The second concept is the replica. A replica is simply a lightweight proxy for a source. Replicas are used on client processes that want to acquire the source object, and yeah, they handle the communication between the host and the client. And then we have a node. A node is just a process on the network. Okay? So, all processes all processes that use Qt Remote Objects form a network. There are two types of node. The first type is the host node. The host node is the node that contains a source object. The second type is the client node. That is a process that acquires a replica of the source. One important thing to notice is that this kind of network is peer-to-peer, which means that each client that you insert in the network needs a one-to-one, so a peer-to-peer connection with the host that is hosting the sources. Okay, so if you compare that with other protocols, it's not the most efficient thing to do, and in fact, this is a solution thought for small networks, a small number of processes that talk together. Okay, enough talking. Let's see how do you create a source object. Okay, it's 3 lines of code, really, and one you would have written it anyway, because the first one is just this. It's just create your object as usual. So this is called control unit, but the main point is that it is a Q object. Then you create a source node, which is of type Q remote object host node, and you give it an URL. Okay. This URL is you need to set it on the client as well. And then, this is the main point, is that you use the source node, you call enable remoting on the source node, and you pass it the object and a name. Why do you need a name? Because single source node may be sharing more than one object. Why not? And so whenever a client needs to acquire a source, it needs to distinguish between different objects. Okay? So we need to name each object we are sharing. So on the replica, on the client part, we need to create a node which is of type QRemoteObjectNode. Notice that this is an object node, and while on the host, the previous slide, we create a QRemoteObjectHost. Okay, that distinguish between a host node and a source node. Okay, then we connect to the node, and we use the same URL we have used to create the source node. And then we just call acquire dynamic. Okay, we call acquire dynamic on the node, and we ask for a specific object. Yeah, so basically that's it. When is the replica ready? The replica is ready only after the initialized signal has been emitted. Okay? Before, it's just an empty shell. As I said, a replica is just a lightweight proxy. So up until the connection has been established, the replica is empty. Okay? You may be wondering what happens if you try to access any method there, any property. Yeah, it returns you nothing, an empty Q variant. It works really well with QtQuick because, of course, all the property connections, property bindings are done directly by the engine. If you use that in C++, you need to do more work on your side. Okay. Next, it's a bit different if you want to share a model. So an object that derives from QAbstract item model. It's a bit different, but not so much. The main difference is that we need to use the correct overload of the enable remoting on the host node. Notice that here the enable remoting is the same, but we are using the correct overload, which is the one with 3 parameters. And again, we are sharing the object, we are giving it a name, and we are giving a series of rows that we want to share. Now this model is visible on the network with the name myModel. On the replica side, the code is more or less the same, except we need to use acquire model instead of acquire dynamic. Okay? That's it. Really. Okay. So Qt remote objects support only 2 connection types in Qt 5.12. One is the local connection. It's a connection that is local only and is possibly more efficient than TCP-based connection. It's on Windows, for example, it uses named pipes. The other one is TCP. It's a TCP connection properly, and it must be fully specified. So you need to write TCP, the address, and the port. Okay, extra connection types are supported, but only as QIO devices. So what means is that you need to establish the connection yourself, and then you need to use add host side connection. Okay, and on the client side, you need to use add client side connection. So if I go back a couple of slides, so for example, if I go back here, you see that here I've used a cure with local control unit, okay? So this is a local connection. I could have used TCP, blah, 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 something. Or, for example, if I wanted to use an SSL socket for security reasons, in that case, I would have need to create the SSL socket on by myself, and yeah, and then use add host side connection on the resulting socket. The same I would have done on the client part. It's just that I would have need to use add client-side connection. Okay, so that's local TCP. Yeah. Okay, so let's review the 5 steps again. I said that, yeah, you need to use Qt remote object on the host process to share all the needed objects, okay? Yeah, we saw how to do that. You need to use Qt remote object on the client process to receive updates from the host. You launch the process with Qt Quick UI on the local screen. Then you launch the client process with platform WebGL, okay? And then you can connect to the browser. You can connect to the browser to the client process. This solution allows you to have 2 screens at the same time on the same application. So if you change state on the host on the local screen, this change will be reflected on the remote part. If you interact with the remote part and change state there, for example, you check a checkbox, or you select something, or some radio buttons, or you scroll the view, or whatever. No, sorry, scroll the view. It's something that it's something that is not sent. It's not synchronized. But anyway, so if you check a checkbox, that on the client, that will be reflected on the local screen. What happens if you want to have more than 2 connections at the same time, more than 2 users at the same time? Well, in that case, you need more infrastructure on your side. So, for example, you could have, for example, a web server which spawn processes, which listens for connections from browsers, and then spawn a process on the fly, spawn a process with platform WebGL, command line switch, and then forwards or redirects the connection attempt to that process. Of course, this is a more dynamic approach. It allows you to have as many client processes as you want with an asterisk, of course. because the more processes you have, the more resources you are spending in synchronizing every process with each other. But anyway, you have a dynamic. This kind of setup is more dynamic than having a fixed number of clients available, but it requires you to have more infrastructure. Yeah. So, as conclusions, you can easily access with the browser to any Qt Quick UI. We have seen how to support multiple users by sharing state between processes with Qt remote objects. If you want a dynamic setup, you still need more infrastructure on your side. I think that the most important part of this all is that you need no deploy. If you ever come up with if you ever encounter this problem, the browser is really something that you want to support because it's everywhere. You don't need to deploy anything. You don't need to build an application. For example, with Qt you can build a mobile application, but then you need to support the Play Store, the iOS Store, and stuff like that. And with this solution, you don't need any deploy. Of course, performance is not really on par with the native applications. So trade-offs anywhere in engineering. Well, who said that? OK, that's it. Do you have any question?
Well, first of all, thank you very much, Luca. Thank you. So, yeah, question time.
Just a question. What about support for Qt widgets UI?
Yeah, for Qt widgets UI, basically your only option is VNC, and yeah, that's not available on the browser unless you can install plugins or more software. I'm not aware of any kind of VNC support in browsers, so yeah, you have to install something anyway. So yeah.
Any other question? Yeah, 2 questions.
Hi. Is there any compatibility problem with the WebGL streaming? Because with the technology called Preview, I've tried with a random application I've written, and I have some problems. I need to disable a splash screen at boot because, I mean, it doesn't seem one-to-one with the desktop application.
Not that I'm aware of. It could be that it matured a bit on 5.12. The problems that I found are with mobile browsers, in that they tend to, with mobile there's touch interaction. And I've seen that, for example, on Chrome, on Android. If you scroll down, it interprets it as a reload gesture for the browser. But I wanted to scroll up in my list view, and then it reloads everything. I think that's something that's something that can be fixed. But as I said, I'm not really so knowledgeable on the web platform, on web front end to understand why it happens. And the same happens on mobile Safari, for example. If you try, it always, from my experience, it is always when scrolling down, if you try to scroll down with mobile Safari, it will move all the view down because Safari does that, and yeah, it's basically unusable for now. But with desktop browser, it works really well.
Thank you.
Hi, you talked about VNC and WebGL to remote the screen using a remote PC, for example. But it's possible to use both the local screen and the VNC or WebGL remote screen together, or the local screen needs to be disabled or headless.
Okay. The point is that each process that you launch can only have one output. So that is because that is why I talked about Qt remote objects afterwards, because each Qt process that you launch, you can launch it either locally. So, for example, you don't give it any command line option. You can launch it as a VNC server, but in that case, it will not open a local screen. And if you launch it as a WebGL server, again, it will not open a local UI, a local window. So that's why you need one process for each client that you want to serve. So you want to serve a local screen, yeah. So you're launching the process. You want to serve a browser, then you need to launch another process with the platform plugin, with the plugin WebGL or VNC, whatever it suits you. And if you want to have both, you need a way to share the state between the two. So that's why I talked about Qt remote objects. Okay.
One question about the WebGL plugin. Do you know what kind of frame rate you can get out of it, best case? Is it like really... Probably it doesn't go up to 60 frames per second.
No, of course. It's, I don't have any measurement, any active measurement, but it feels like 30, 20, 30 frames per second, depending on your platform as well.
Okay. And do you know how that compares to the VNC plugin?
No, not really.
I guess similar maybe, or...
Yeah, it seems similar. And that's more dependent on bandwidth, anyway.
Okay, thanks.
Okay. You said that replica object is a Q object, is it?
Yes.
So could I use this object directly? Can I pass this object directly to QML engine?
Yes.
Wow. Okay.
Yes.
That's what. And if I can, another thing, you can pass Q object or a Q abstracted model.
Yeah.
So I think there is some message that is passed through the replica and the source objects, like data changed, they use the indexes. So the question is, if I have a huge source, when the replica connects to the source, all the data is downloaded to the replica or on demand.
Yeah, it's a bit smarter than that. In particular, with models, you have a method which is called the canFetchMore, and the replica model it uses that to avoid fetching everything right from the start.
Okay, so if I develop my own model, I have to use canFetchMore.
Yeah, I guess so.
Yeah. Otherwise, all the data is on the connection is.
Yeah.
Yeah. Thank you.
It was the same question.
Okay.
Any other question? Yes.
A question about WebAssembly, I don't know. You said that I can compile a C++ application and execute as a web application. What does it mean? If I have a C++ application that communicates with serial bus, all the application is executed in the web browser, or can I have a headless solution where the logic and the serial communication stay on the headless device, and only the remote, the UI is remotely by WebAssembly?
Okay, the WebAssembly option is atypical in the, if you compare that with the other two options. So what happens with WebAssembly is that you compile, what happens with WebAssembly is that you have more website than a regular Qt application. So you can compile, what happens if you use Qt for WebAssembly is that the Qt libraries are compiled to WebAssembly, and then when you connect with your browser to the test, to the server, the server will send you the whole Qt libraries compiled for with WebAssembly, and then it will use that library to draw on screen on the browser. But that's it. So Qt are used only to draw on the screen. If you want to do, but the application is sandboxed. In that case, the application really runs on the browser. So it can do as much as a regular web page can do, okay? So it cannot, for example, open a serial port. There's no concept of serial port in the browser. And a regular web page cannot open a serial port, cannot write to devmem, cannot spawn processes, cannot open file dialogues. It can, but it cannot open any kind of dialogue. Okay, so when you have a web, an application compiled with WebAssembly, you are dealing with more of a web page than a regular application. If you want to access a serial, you need to have a web server on the machine that answers to the requests of your application. So you have the application that is running on your browser, but that application needs to do HTTP requests to a host, to a web server, and that web server will answer. So if you, to say it with other words, you need to have one running process, which is the web server, which will answer requests, and that will open the serial port. For example, on the headless device, you will have a process that will act as a web server. Then you will have a Qt application compiled with WebAssembly that will be served to browsers that connect to the device. But then that application will make requests to the web server, and the web server has the data. Okay, it's more of the WebAssembly option is really very different from a regular application. You are acting in a web page as if you were a web page, and you don't have. You can only issue HTTP requests, or you can open WebSockets or something like that. Right?
Yeah.
There is a way to use a remote object with authentication or some sort of login?
Yes and no. So, no. The answer may be no, in the sense that it's not supported out of the box by the connection types that Qt Remote Object supports right now. The answer may be yes, because if you do the boilerplate on your side, yourself, you can just pass a QIO device when you have opened the connection and you have established the connection, for example, a TCP connection, and you have authenticated a user, then you can pass this TCP socket, which is a QIO device, and use that.
We were talking about remote stuff, possibly internet, and you mentioned security. How about that?
Yeah, again, it's not supported out of the box. You can open SSL sockets on your own and then pass it to the nodes to connect with them. There are examples as well on these. Yeah. So no support out of the box, but you can do that. It requires a bit more of code. It's not 5 lines.
We are here.
A question about the WebAssembly that run on the browser, but there is a tool chain that produces this bytecode or not?
Yeah, exactly. You need, to use WebAssembly, you need a specific compiler, a C++ compiler that emits WebAssembly bytecode. It does not emit assembly code, regular assembly code, Intel code, ARM code, or whatever, but it emits WebAssembly code. And yeah, you need more than that. That is just assembly code. It runs on the browser, but to use it, you need regular JavaScript. You just need vanilla JavaScript to interact with the user, to change DOM nodes, to change HTML nodes, or to paint something. That is done with regular JavaScript.
Hi. I'm wondering if remote objects can be used together with WebAssembly, like Replica within the WebAssembly code and talk with an host application.
Yeah, no, they're two different words. They're two different words. So if you have, if you have an application that is compiled for WebAssembly, in that case you cannot do. You can only issue HTTP requests to a browser. Okay, so Qt Remote Object is just something that it's something that allows you to let two processes communicate together. Okay, they may be on the same machine, they may be on different machines, for example, but that's it. Qt for WebAssembly is just a different way to deliver a Qt application. They're two different words. They serve different purposes. Qt remote objects serve to synchronize two processes together. Okay, Qt for WebAssembly is another way. Let's say roughly is another way to paint a Qt application on the browser. Okay, so it's yeah, they are orthogonal concepts. Okay. Does it answer your question?
Yes, but if I have an host application with RAM some code, and I have client-side application which is just WebAssembly on client browser, so they must communicate.
Okay. Okay. Okay.
I guess I can use remote objects. I don't know if feasible, but
yeah, it could be that you could use Qt remote objects, but it may be the same application as well. So if your clients are if your client is an application with Qt for WebAssembly, in that case, that application is fetching data from a web server. So the web server maybe let's say the web server is on the an embedded process, is on an embedded system. Okay, in that embedded system you have a local screen. Okay, and this local screen, there is an Qt application that runs and draws on the local screen. Then you have something with, then you have another process that is a web browser. It's a web server that serves, it's a web server that serves an application with WebAssembly. Okay, this server serves the application to the other to the browsers, and then to fetch the data, this server needs to communicate with the process that is displaying stuff on the local screen. In that case, you can use Qt remote objects. Yes. Okay. But the WebAssembly stuff is there. It just needs to. It is needed to paint something. It's okay. It is served. Is just a file, like a regular HTML JavaScript file that is served to a browser. Okay.
Next.
When the replica connects to the source via TCP connection, reconnections or if you are disconnected, it is handled automatically by the framework, or is up to the developer to, let's say, handle that kind of situation?
If you're using the connection type supported by Qt remote objects, that is completely automatic. And you don't need to do anything explicit to support this. So if the source goes down, so if the host node goes down and it's disconnected for some reason, then the replica and the client node recognizes this event, and it recognizes it and tries to reconnect to the source. So that is automatic. I'm not sure, but I guess if you are doing something else, so for example, if you are doing an SSL, if you are creating an SSL socket on yourself, so if you're using the QIO device option that I gave you in the last slide, in that case, I think you need to do all this stuff on yourself.
What about when you are disconnected about signals, for example, are queued, are kept in a queue, or are lost, or try to, or when from a replica you try to access a property on a source, you keep, let's say, blocked, you get an invalid value as a return?
yeah, you get an invalid value. So, yeah. So if the connection goes down, you get no, actually, the value, sorry, actually the value is cached. The last value that you had is it's that.
And for the signals?
Yeah, you don't receive any because the signals that the signal that the replica emits are just proxies for the source object. So if the source is down, it cannot emit any signal, and you don't receive any signal as a consequence. Is that good?
So I think we have time for one more question. Yeah. Will be the last one.
So yesterday we talked about the registry.
Mm-hmm.
So there is a mechanism of registry, so you can
yeah. Okay. I haven't talked about. Okay.
Yeah. The question is that since that registry is not well documented on the Qt. On the documentation of
many
a
other
remote
things.
object, yes.
But pardon, sorry.
On the documentation of a Qt remote object, a registry is not well documented. Maybe I used an old documentation, but it seems it's not well documented.
Yeah, it's yeah some more.
How can I use the registry? Is the question.
Yeah, I haven't shown it here. So basically, there's this kind of there's this kind of method which is the registry. Yeah, it's going to be long. So let's keep it afterwards, and we can talk about it. It's going to be too long now to answer this question. Sorry. Well, we can talk later.
Well, thank you very much, Luca. Thank you for your time.